Welcome back to statistics. In this video, we want to look at how we can understand categorical data using bar charts. So let's take a look. As we've seen, what we're interested in looking at a data set is the distribution of the variables in the data set. We've seen how histograms and dot plots can help us understand the distribution of a quantitative variable. Now we want to look at how bar charts and briefly pie charts can give a graphical representation of the distribution, of a categorical variable. So I want to use some data from 1,000 US men and 1,000 US women who were asked, how important is it to you personally to be successful in a high-paying career or profession? We can quickly see the results of this survey in a bar chart. And here it is. So I've combined in this chart the responses from the men and the women. So we have 2,000 individuals in the sample. They're all 18 to 64 years in age. And here you see the responses. The possible responses are on the x-axis: not important, somewhat important, very important, and most important. So those are the values of the variable, we'll call it importance, the response to the question that was given. And here you see the distribution of those responses. The most common response was that it was very important to have a successful career, but it not the most important thing. In fact, those who responded that it was the most important thing to be successful were actually the smallest group in the sample. The second largest group were those who responded that it was somewhat important, and the third largest group was those who responded that it was not important at all. As we did with histograms, we can make the chart a little more explicit by reporting the frequency of each response above that bar, so you get the exact numbers who responded in each category there. One difference between a histogram and a bar chart is that in a histogram, these bars would be right next to each other. They would be adjacent. But in a bar chart, we don't do that. And that's because it's a categorical variable. We indicate that by putting a gap between the categories. And actually, for a lot of categorical variables, you could rearrange the categories in any order. In this particular case, the order we have here kind of makes sense because it's sort of an increasing order of importance. Not important, somewhat important, very important, and then most important. We call this kind of data or this kind of variable an ordinal variable because there's an order to the responses, and we've respected that order as we've listed them here in the chart. We could also represent this data in a pie chart, and that you see here. In a pie chart, the areas of the various wedges correspond to the frequency of the responses. The pie charts are fine, they're easy to read. In statistics, we basically prefer bar charts, and we're going to focus on those because they're a little more versatile in the ways that you can display the data, and we'll see that in a few seconds here. Here's the raw data that these charts were built from in spreadsheet style. I'm just showing you the first 10 of the individuals in the data set, so there's a whole bunch more. But here you see that we have multivariate categorical data, right? Because there's 3 variables in this data set. The first one is gender. For each respondent, we recorded their gender, female or male. Then we also recorded age for each respondent. It was categorized into 2 groups, 18 to 34-year-olds and 35 to 64-year-olds. So the age variable has been binned, and therefore it's now a categorical variable. And then the third variable is importance. And we've seen that that variable had 4 different values: not important, somewhat important, very important, and most important. So we have multivariate categorical data here. And you could look at each variable individually in the data set. So here's a bar chart for the variable gender. As we saw, we have 1,000 men and 1,000 women, so both bars have the same height, and it's 1,000. Here's the bar chart for the variable age group. There are two values, remember, 18 to 34-year-olds and 35 to 64-year-olds. And you can see here that there were more 18 to 34-year-olds in our sample than there were 35 to 64-year-olds. And then, of course, the variable importance, and we've already seen that bar chart. Another thing we can do in multivariate data is look at relationships between the variables. For instance, is there a relationship between gender and importance? In other words, do men and women differ on how important success is in a high-paying field? And here I'm using what's called a segmented bar chart to visualize that relationship. Among the 1,000 women respondents, I've segmented their bar into those who responded that it was very important to have a successful career, somewhat important, not important, and most important. And then we've done the same thing over here for the men. So you can already see that there are some differences between men and women here. More of the men think that it's very important than the women. 346 women thought it was very important, but 462 of the men did. And remember, the group sizes are the same here, 1,000 women, 1,000 men. So we can see that men are more likely to think that it's very important than women in our sample. The same thing for the most important category. More men deemed it the most important thing to have a successful career than women. Uh, on the other hand, if you looked at those who responded that it was not important at all to have a successful career, here you see that quite a few more women made that response than men. So we do seem to see here that there does seem to be a relationship between gender and importance. A person's gender does have an effect on how they rate the importance of a successful career. Another way you could kind of look at this is the ranking. How do men and women rank the importance of success? And so, what you would do here is look at how the categories, the values of importance, were ranked by the 1,000 men and the 1,000 women. Among the women, the very important response was the most common, followed by somewhat important at 296, and then not important at 278, and then most important at 80. Among the men, the ranking was a little bit different. Again, the largest group ranked it as very important to have a successful career. The next largest group was again the same as the women, somewhat important. But then the third largest group among the men was most important, whereas the third largest group among the women was not important. So there is a difference in the rankings of importance among the men and the women. The most common responses were the same among men and women. Second most common were also the same, but there's a difference in the third and fourth most common responses. Men and women sort of flip those categories. We could also look at a relationship between age group and importance. Do younger and older workers differ on how important success in a high-paying field is? Here you see that same kind of segmentation where I've taken the 1,199 responses from the 18 to 34-year-olds and segmented them into those who responded that it was very important. There were 500 of those. Somewhat important, 291, and so on. And I've done the same for the 35 to 64-year-olds. Here you could also look at a ranking, and it turns out that the ranking is the same between the two groups here. That is, both age groups have the same ranking of importance. Very important was the most common response, somewhat important, followed by not important, and then most important. So both age groups gave the same ranking. But the The comparison is a little more difficult in this case because there aren't the same number of responses in each group here. There were almost 1,200 responses in the 18 to 34-year-old group, but only around 800 for the 35 to 64-year-old group. So to make a one-to-one comparison a little more doable, we could use percentages instead of raw numbers, and that's what's usually done when the group size differ. So now my y-axis here is percents, and both bars have 100% height because I'm, I'm putting all responses from the 18 to 34-year-olds in their bar and from the 35 to 64-year-olds in their bar. So that's 100% in both groups. But the segmentation is now done on the basis of percentages rather than raw numbers, and so we can make a comparison, right? Uh, the among the those who responded, it was very important. The percentages are roughly the same between the two groups. About 42% in the younger groups thought it was very important. About 39% in the older groups thought it was very important. But you see some differences among in the other categories. Uh, a larger percentage of the older workers ranked it as somewhat important to have a successful career than did among the younger workers. And when you see differences like this, you might be inclined to ask, well, what causes that difference? What is there an explanation for that difference? And at this point, we could only speculate, but you might, for instance, think that maybe a larger percentage of the older workers think it's somewhat important because maybe retirement is more on their minds than others. And in the same way, you see a difference in the between younger and older workers in the percentage who ranked it as not important at all to have a successful career. 21.4% of the younger workers responded that way, but only about 15% of the older workers thought it was not important to have a successful career. And that, again, we might speculate would have something to do with the fact that the older workers have more responsibilities on their minds, maybe retirement or maybe paying for college for their kids and things like that. So a segmented bar chart usually is done in terms of percentages, especially when the group sizes differ. So let's take a look at the ebook and see what it has to say about this. We're still in Module 6 here on graphical representations. 6.2a covers the basics of bar charts, just pretty much as we did in the slides. 6.2b is interesting because it gives another way of looking at making comparisons with bar charts. And let me just show you this example on prison effectiveness to illustrate this. So a poll was taken in a small community to gauge thoughts about the effectiveness of prison time in deterring future criminal behavior. So one question was, do you believe that those who serve at least 10 years in prison are likely to commit crimes again once released from prison? So this category is labeled opinion in this table you see here. So a yes answer means that the person did believe that 10 years after 10 years in prison, an inmate would be likely to commit crimes again. A no answer would say, no, I don't believe they would. A second question was, have you or any of your family members served time in prison? So this gauges a respondent's sort of direct acquaintance with what prison time might be like. And this is the response labeled prison in the table. So we have, let's see, 1, 2, 3, 4, 5, 6, 7 individuals in the sample, and they gave a response to each of those questions. Do you believe folks who are released after 10 years are likely to commit a crime again? That's the opinion response. And have you or a family member served time in prison? That's the prison response. So we'd like to understand this data. In particular, here we might ask the question, does direct experience with serving time in prison, either on a person's own part or on the part of a person's family member, does that have a bearing on whether they think a person is likely to commit crimes again after being released from a 10-year prison sentence? Let's think about that question and see if the data give us any uh, insight into it. So here is that data uh, sort of formatted to address our question here. We've sort of grouped those responses into two groups. The first row in the table here is from the group who did not have direct acquaintance with prison time. So these people did not serve in prison themselves, nor did they have any family member who had served time in prison. And of those people, two of them thought that it was not likely that a person released after 10 years would commit a crime again, and one of them thought that it was likely. And then in the second row of the table, we have the responses of those who did have direct acquaintance with serving time in prison. Of those individuals, three of them said that they did not think it was likely that a person released after 10 years would commit a crime again, whereas one of them said they thought it was. So we have those seven responses here kind of broken down and categorized in terms of those who have direct acquaintance with prison and those who don't. And here you see that data represented in what's called a comparative bar chart. What we've done, again, because there are different group sizes, there were three individuals in the sample who did not have direct acquaintance with serving time in prison, and there were four who did. So we've converted the data into percentages. Among the three individuals who did not have direct acquaintance with serving in prison, 66%, two out of the three, right, uh, did not think it was likely that a person released after 10 years would serve time and would commit a crime again, whereas 33%, or one out of three, did believe it was likely that a person would commit a crime again after serving 10 years. On the other hand, among those who had direct acquaintance with serving time in prison, three out of those four, or 75%, answered that they did not think it was likely that a person who served time would commit a crime again, whereas one out of those four, or 25%, did think that it might be likely that a person who served 10 years would commit a crime again. So by converting those values into percentages, we can make a comparison between those two groups. And what you see is that there are some small differences between the groups, uh, but not large ones. In other words, there doesn't seem to be a significant difference between those who have either themselves or a family member served time in prison versus those who haven't, in the opinion about whether a person released after 10 years would be likely to commit a crime again. The majority in both groups, and it's a pretty large majority, would say that they don't think it's likely that a person released after 10 years would commit a crime again. And but there is a minority in both groups who believe that a person is likely to commit a crime. So what we would say from this is that there doesn't seem to be a strong relationship between uh, direct experience, whether you or a family member have served time in prison or not, and your opinion about whether 10 years in prison is going to deter you from committing another crime after you're released. There doesn't seem to be a strong relationship between those two variables. And so that's useful information. Let's take a look at what they have to say about segmented bar charts as well, and that's in section 6.2C. And let's see, I'm just going to skip straight to an example. First, let's look at coal transport in the U.S. So, rail, according to the USIA, rail remains the primary transportation system for coal in the United States. Uh, and then we're given data of the percentage of coal that's transported by railroad, intermodal rail, waterway, truck, and so on in various years. And so in 2008, 59% was transmitted by railroad, 7% was intermodal, 7% was waterway, and so on. And there's an other category here that would comprise all other possible modes of transportation. And if you add up the results in the 2008, you'll find that that does add up to 100%. So we've really categorized all possible ways of transporting coal in this year by these in these various categories, with the other category kind of being a catch-all category. And then you see a similar thing for years 2009, 10, 11, 12, and 13. And so let me just show you the display of this data in a segmented bar chart. And this enables us to compare the various modes of transportation across these years. So year here is the category that we're making the comparisons across, and we can compare the fraction that were transported by railroad, intermodal, and so on across those years. And so you can see some relationships here across all those years. Rail is still the primary source, although you do see some fluctuation in that percentage across the years. And another interesting feature is this other category seems to just disappear as we progress from 2008 to 2013. So there's actually a lot of data here. And as usual, what we're seeing again, and this is something that we saw with histograms as well, is that there's a lot of data that's summarized in these charts, and one of the things that we'll be kind of coming back to again and again is just being resourceful and sort of observant, keeping your eye peeled for relationships that are evident in these graphical summaries of data sets. I wanted to look at one quick other example before we wrap this one up, and that's still in the segmented bar chart section. So let me find it. Bear with me. Children of immigrants and poverty. Let me just kind of skip to the bar chart here. What we're looking at is the relationship between the fraction of children who live in poverty and its relationship with whether one or more of the children's parents were immigrants. And so, and we're looking at that across various states. So, for instance, if you look in California, it looks like about maybe 65% of children with at least one immigrant parent uh, live below the poverty line, but it looks like the corresponding percentage among children with native born parents is around 35%. So you can see that the the percentage who live below poverty does have a relationship with whether one or more of the parents were immigrant born. A child is more likely to live in poverty if one or more of their parents is immigrant born, and that's the case in actually pretty much all these states. Florida less so. Florida, New York, and New Jersey less so, but California, New York, and Texas, it certainly seems to be the case. So, yeah, that's segmented and comparative bar charts for categorical data. We will have some homework on this as usual, and let me know if you have questions, and we will be back at you soon. Y'all take care.